Conquerx with Metachip.
Thank you. Have a good evening, everybody. My name is Deborah Zanforlin. I am CEO and co-founder of Conquerx, and I'm here today with my CTO, Jacob Schudig, and back my CBO, Ricardo Ramirez. And today we're going to present to you our first live demo of our cancer diagnostic test. So what we are developing in Conquerx, we are trying to solve one big problem, that is the early detection of cancer. So we know that as early we detect, as early we can treat and save lives. The problem is we only have early detection screening for at least maybe 5 types of cancers. And there is 100 of different types of cancers out there, right? So what we're developing is a technology called Metachip. This is one of the chips that we are developing. These chips combine material science, machine learning, and software to detect different types of cancers, I would say. We now are working between 10 to 12 types of cancers, and the way that this works is pretty simple. We detect different classes of biomarkers. We detect DNAs, microRNAs, proteins, and I will not get too deep to not get very boring to you on the science, but instead of going to 23 different hours of sequencing, PCR, what our technology does is we can customize to detect DNA, microRNAs, and proteins in one single sample. We develop a nanocompose that enables us to detect this material without PCR, and we are working through machine learning algorithm to pick what's the most accurate panel to detect this type of cancers. So the way that is bring a new innovation is, first, in one single test, we are able to detect multiple types of cancers. So instead of you not be able to detect or screen for liver cancer or pancreatic cancer or lung cancer, with Conquerx tests, we'll be able to, once a year on your annual checkup, detect this type of cancers. We are pretty cost effective comparing to sequencing and other technologies, and we are very unique. We are the only technology that's targeting detect microRNA, DNA, and proteins at the same time. And the advantage of that is that we can combine the accuracy of each class of biomarker, create a better panel, a most accurate panel for detecting, in this case, cancer, but in the future, also other diseases. And tonight we're going to show you for the first time our first MVP, how it works. So technically, please don't worry about the design. We're going to worry about this later on. But the way this works, we take the sample of the patient, we have our software, right? We add the name of the patient, the data, and we load the measure. On the back of the table there, we have one chip like that. And this chip has the nanocompose that we patent, plus the solution that's being ready right there. He already pressed start. This technically to read, could read between 12 to 20 biomarkers. Right now we're reading one. On the end, it must be at least 1 hour of reading, because we're only reading one biomarker that will take about 1 minute. And soon you guys are going to see some graphics showing up that's supposed to be detecting the DNA that we already put there, because that's a lab work, so we needed to bring that from the lab here. We couldn't do that right here. For the patient, it means that he will go to a lab, draw the blood, the technician will add some reagents on it, and we'll plug this chip on the hardware, and then the data will come out of that. And the beauty for that is pretty simple. So we can put on a very fancy hospital, or we can bring to a not very fancy hospital from a Brazilian hospital. So this accent that you're hearing is because I'm Brazilian. So this technology could be applied to very fancy hospitals or rural areas because it's very portable. So on the end of the measurement, the software will analyze the data from all the biomarkers that we put. This is the data from one biomarker. And then we can put all together. And then we change to explain you why we're the best. So here I am, I'm the CEO of the Conquerx. I have some IPs in the past, and I'm the inventor of the technology. We have Jacob from MIT on the software developing. We have our amazing handsome CBO doing our business and increasing our partnerships. We also have an amazing set of scientific and business advisors covering business, sales, science, that we can go from Harvard, Tufts, and MIT. And then we're around at least 3 years by now. So we ladies and gentlemen, are fundraising. We're currently fundraising our seed round, $2 million, and the goal is to go to 1,000 patients. So if you're an angel investor, or if you work in research in oncology, or our connections, we are happy to connect. We're looking to collaborate with different researchers to prove that our technology is working, not only with our biomarkers, but with all different biomarkers. So now I'm open to questions. So the blood sample is a normal draw of blood sample. So the patient will need to go to the hospital to at least 1 ml of blood. In our technology itself, we only put like 10 microliters, but it's not 10 microliters of blood. It's blood with some reagents on it. Sounds perfect questions. So we did a pilot test before with breast cancer patients back in Brazil. We got 90% of accuracy, 90, just to make sure that my English was correct. And we did that to prove that we were able to detect the biomarkers on the patient samples. And now we are increasing the set of the patients to 1,000, so we can actually prove that in a bigger set of patients. I'm sorry? We didn't publish because we just submit our IP. So until this last years of work, we were working to get our IP done. So maybe the next month. Actually, it's not a very similar story. So what she did was fraud, for start. And we are not doing a drop of blood. So we're taking normal amount of blood, and we're actually doing a half of extraction from that blood. So technically, we are not promising any drop of blood in our strip, right? I said that at least we'll need 1 ml of blood. What we are doing, the novelty is related to how we can detect these biomarkers. We had data previously with breast cancer. We also proved with DNA. We are now with a collaboration with Brigham Women with up to 100 patients that we are ongoing collaboration. So the difference is, like, I think she tried to do a drop of blood for different kind of things. What we are doing, the novelty for us, is how we can detect multiple classes of biomarkers at the same time. So that's not only going to be helpful for cancer, but for drug development, or to detect if a drug is working or not, or precision medicine itself. The technology itself is agnostic. We can customize that for different purposes in the end. Thank you. Okay.